Hi everyone, we're going to show you a way to analyse the vitamin C content in just about anything you want really, and we want to show you a way that you can do it at home using ingredients that you can buy. So we've given you a kit, and in that kit you've got some vitamin C tablets. You may have this brand or you may have a different brand. It doesn't matter which brand we use, as long as it's soluble and as long as we've got a tablet that is 1000 milligrams of vitamin C. So the first thing you're going to do is set up your standard solution. Your standard solution is one where you know the concentration. So we're going to add 1000 milligram vitamin C tablet to 1 litre of water. Now we're doing this in a chemistry lab, so we've got laboratory glassware, but in a kitchen you could use a measuring jug. It doesn't matter. It's just a container and have 1 litre of cold water in it and dissolve your tablet. Okay? So I'm going to leave that aside. Once it's fully dissolved, we're going to know the concentration in that solution. So our vitamin C stock standard solution is 1000 milligrams of vitamin C in 1 litre of solution. So that's important. Next thing we want to do is prepare what it is we want to measure while we're waiting for that to dissolve. I'm going to measure vitamin C content in kumquats. Okay? But you can use anything, which is pretty exciting, I think. So in the kitchen you might have a mortar and pestle or a little juicer. You could have scissors and a knife so you don't have to use your fingers. So what I want to do is I want to extract about 1 milliliter of juice from my kumquat. I might need a couple. So 2 kumquats should be enough for me. So I'm going to try and crush it a bit more just to make sure I've got enough juice in there. But in the kitchen I'd use a mortar and pestle. Now in your kit you'll have a couple of these little plastic dropper pipettes, but if you didn't have one of these you could use a syringe that you could get from the pharmacy, and you could measure out 1 milliliter of this solution. So I'll measure that out in a moment. Just let that steep a bit longer. Another thing I need to do is make sure I've got my indicator solution, and that's going to be a starch solution. We are going to be using a cornstarch solution in your kit, but today I don't have cornstarch. I've got starch in a laboratory container, but it's the same as cornstarch. The amount of starch you use doesn't really matter as long as you've got quite a lot. You want a very concentrated starch suspension, okay? So I'm putting the starch, which in your case will be corn flour, in hot water. I put it in 100 ml of hot water, but it doesn't really matter what volume you use as long as you've got a saturated solution. So you want to add heaps of starch so that some of it dissolves, but not all of it. So if I've got a little bit of solid on the bottom, it's saturated. Okay, so a very concentrated suspension of starch. Now the good thing about starch is that it actually reacts with iodine. So if I put a little bit of my starch in here, doesn't matter exactly how much, in the presence of starch, iodine will react. So our source of iodine is coming from the pharmacy, and we've got some betadine antiseptic solution. it has equivalent to 1% of available iodine. Okay, so that's what we're going to use as our indicator. In the presence of starch, iodine will complex with the starch and form a dark blue coloured complex. So I've added 1 drop of iodine in there, I mix it up, and we can see a really nice dark blue colour. So that's really important. Another thing we know is iodine reacts with vitamin C. So that's the whole point of the experiment. So my vitamin C tablet has fully dissolved. Yeah. So I'm just going to give that a mix just to make sure I've got a uniform and homogeneous solution. Which I do. I'm not going to use all of that solution. I'm just going to use 1 ml or 2 ml. It doesn't really matter as long as you can measure it accurately. So in the lab, I actually have, this one's a bit wet actually. I think I need a dry one. No, that's okay actually. What I can do is I can rinse it. I've got enough solution, but I've got excess. So that little bit of water that was in there, I'm going to put in here and just use it to rinse this out. So it's now clean. Okay. So I'm going to start making a calibration curve. So to do that, what I'm going to do is measure out accurately different volumes of my standard solution. So I'm measuring out 2 millilitres. Now you might have a measuring cylinder in your kitchen, I'm not sure. If you don't, that's okay. You can use a teaspoon and you can say, well, I'll do 1 teaspoon. That's 5 ml, I think. Then you can do 2 teaspoons for your next one, and that'll be 10 ml. Or you could use the little medicine cups that you can get from the pharmacy, and they are often graduated as well, and you can measure out small volumes. As long as you can measure out, I reckon about 2 ml for your first. I'm going to do 4 ml for my next one. You could go 1, 2 and 3. I'm going to go 2, 4 and 6. So remember, we had the stock solution having 1,000 milligrams of vitamin C per litre. So each milliliter is going to have 1 milligram of vitamin C. So this beaker contains 2 millilitres, so it should have 2 milligrams of vitamin C. This one will have 4 milligrams, and this will have 6 milligrams. And iodine will react with that vitamin C. What I'm going to do is put a big chunk of starch into each of these, so I can see when all the vitamin C is being used up. Okay. So it doesn't matter, you don't have to measure it out accurately as long as you're consistent. So with this, I've had to mix it up because the suspension's gone all a bit thick at the bottom. Okay, so 1, 2, I reckon 3 good healthy squirts will be a great start. So now, in theory, what's going to happen is I'll start adding the iodine to this beaker. It's going to react with the vitamin C much more quickly than it reacts with the starch. So the vitamin C is the preferred reaction. Iodine will react with vitamin C until there's no vitamin C left, and then it'll start reacting with the starch. So all I need to do is add this drop by drop and count how many drops I add until it goes bright blue. As soon as I see it go bright blue, I know the starch iodine complex is formed and there's no vitamin C left. So how many drops of iodine do we need to react with this much, 2 milligrams of vitamin C? 1. Now you've got to give it a good mix. There's 2. You can see it's gone a little bit brown, but it's not that blue colour. I mix it up and that colour disappears. So we're not there yet. 3, so we've got to mix it well after each drop. 4, 5, it's taking longer for it to disappear and it's teasing us with a little bit of blue colour, but then it does disappear completely. 6, 7, 8, 9, ooh, there was a bit of blue there, I don't know if you saw it. 10, oh, and look at that. I'm right-handed, so I'm going to give it a big mix. The blue colour has appeared, the vitamin C's gone. So 10 drops of vitamin C in my first one. So I'm going to start plotting that on a graph. Okay? This is where I construct my calibration curve. Okay? On the x-axis, down the bottom, I'm going to put my independent variable. That's the one that I control. Okay? So my independent variable is what I've controlled in the experiment, and that is the millilitres of vitamin C. So millilitres of vitamin C. That was 1 milligram per milliliter in concentration. Okay. So now hopefully you'll use actual graph paper here that has a good calibration. And up on the y-axis, I'm going to put my dependent variable. That's the variable that depends on how much of this variable we're using. Okay, so it'll change in response to how much vitamin C. It's what we're measuring. We're measuring the drops of iodine that we need to add to react with all of that vitamin C. 2 millilitres needed, 10 drops of iodine. So there's my first data point. Okay. So now I've got my 4 millilitres of vitamin C. If this goes according to plan, I've got double the amount of vitamin C. I should need about double the amount of drops. 22. Now we've got the blue colour. So 22 drops. So that's pretty good. Now we're not using volumetric glassware, so we don't expect it to be perfect, but it's still a good range here. So 4 drops required, 22. So there's my second data point. I should confirm it by having at least 3 data points in my calibration. So here's my 6 mil. Oh, 32. I'm a little unsure. It's kind of not as bright as before. So I'm going to keep 32 in mind and add 1 more drop and see if that 1 more drop was more convincing. It was definitely more convincing. So I think we weren't imagining it at 32. So I'm going to say 32 and a half. So 6 mil of vitamin C required 32 and a half. So from this I can draw a line of best fit through 0, and I've got a calibration curve. So what that means is I replicate this same experimental technique on my unknown, which is my kumquat. Okay, so that's 1 milliliter. Right there. So what I could do if I want to just make that volume a little easier to see is I could add a little bit of water if I wanted, because I've got 1 milligram of the kumquat measured in there. I know that any vitamin C in this beaker is coming from that 1 milliliter of kumquat juice. Okay, so that's a little bit easier to work with. I can't forget my starch. I have to add the starch to that, and I have to add the same amount of starch, approximately, as I did with all of the standards. So now all I have to do is see how many drops of iodine it takes to react with the vitamin C in the kumquat. 1. Now this is my unknown. I actually have no idea. So if that went blue straight away, then I know that it either has no vitamin C or its vitamin C content is very, very low. And I would need to concentrate it or choose something else as a source of vitamin C. Okay? If it doesn't turn after about halfway through my calibration curve, then I know that the vitamin C content is too concentrated, and I would need to dilute my unknown, maybe not use a whole milliliter, but use 1/10 of a milliliter, or even a drop or more, or 2. So that was 2 drops, and it's actually started to turn already. 3, so 3 drops. Okay, so my kumquat, 1 milliliter, took just under 3 drops to react with that iodine. So I can now read off my calibration curve. Just under the 3 drops were added, so about here. That's the drops of iodine needed. I read across here and drop down, and I can read off the x-axis the concentration of vitamin C in that unknown that I measured. It's just over 1 milligram of vitamin C per 1 milliliter of kumquat juice. So that's pretty exciting. So that's exactly what you're going to do at home, choosing anything, and I would just say that you should repeat your experiment a couple of times to get an average, just to make sure there's no outliers. But be aware that you've only got 1 bottle of this to react with. So thank you for watching. Good luck with your experiment.